Everybody, my name is Daniel Lapuna. I also go by Daniel Acuña. If you want to say it like that, that would be great. I have 5 names, but I won't reveal them because it's just too long. I was in the School of Information Studies at Syracuse University, but I'm moving to the computer science department in lovely Colorado. That's where I'm in here in this fake library behind me. I don't want to show the messy room that I have. I'm moving. I drove 4 days from Syracuse, which is like 1,600 miles, like 3,000 kilometers away from this place. My background is computer science, and I try to use artificial intelligence and apply that to science in many ways. So sometimes I do just science, basic science, or sometimes I do science of science. And I usually try to do like predictive analytics. And I'm just excited about all these amazing data sets that are coming out. Something interesting and funny about me, man, I cannot think of anything, but I guess I drove, and you don't want to drive in Colorado with a truck because the roads suck, and I'm looking for students. So if you are interested in applying to Colorado Boulder, please feel free to send me an email. Thank you.
Okay, I guess I'm next. Hi, everyone. My name is Stephen David. I'm at Oregon Health and Science University. I kind of already gave you a few hints about who I am. I'm helping Daniel organize this. He's really the mastermind, though, so all complaints should be directed to that guy. But as I mentioned, I started off and still am a neuroscientist. So in my day job, I'm interested in understanding neurons and networks of neurons and how they communicate as a system, in my particular case, to understand auditory processing. But I've always had an interest in kind of how does this fit into the bigger the world of science and neuroscience, and even fields outside of neuroscience, which neuroscience draws on. And so this awareness that maybe the ideas of understanding networks in the brain, which are very complicated and not really understood, those same kind of questions and ideas exist in the science of science. And so I kind of look at people and sort of think of them as like big neurons, right? I guess each brain is like a big neuron, and just sort of on this big multi-scale space. And so that's kind of the background that I bring into this. And I'm so happy to chat with any of you whenever there's a chance about this work. As Daniel mentioned, we started a project several years ago looking at this academic mentorship data set, and have done sort of published some studies and would like to share this data set with you. Very interested in helping you use it if anyone wants to kind of explore questions around mentorship. So please feel free to bug me here or in Slack. Yeah, what's funny about me? It's now 7 a.m. in California, so I know some of you are probably about to go to bed. I'm still desperate for some coffee, so I really love coffee. So I don't know if that's funny, but it's true.
Yeah, let me jump in here. I'm not gonna share this, and I'm gonna record this. I'm gonna pause it, and I'm gonna pin myself. Let's see here. And then I'm going to share my screen. My screen should be my screen. So let's see which ones I want to share. Suspense here. All right. All right. So in this survey that after you were admitted and you registered, you had to fill out the time that you were going to do the check-in and also your GitHub account name. Okay, so that GitHub account name is for accessing this environment that we built for you, where we will have yes, so I hope to put the 2 lectures together. I think that will leave us a break. We don't necessarily need like a 30-minute break in between now and Lijian's lecture. So maybe we'll do like a little lecture, a little break, but not 30 minutes. All right, so you share the GitHub account with me. And so I want you to go to this address, and I'm going to put it on Slack, not Slack, on Zoom and Slack. Why not? And where should I put it? Let's see, random. It's not really random, but I'm going to put it there. Okay, so if you click there, it will take you to this page, and then you should click sign with GitHub. Now, I already signed in and I already gave the permission to this system to use my GitHub credentials. Okay, so if you click here, it will take you to GitHub, and GitHub will tell you this website is asking your permission to use your credentials. Okay, so I won't see that. So if I click here, I would immediately sign in because I'm already authorized. So when you sign in, you will see this, and that's the only option available. So there's nothing. We used to have several kinds of servers, but this is the only option available. So you click start. And of course, there will be many errors. I hope that we don't crash the server, but if you click, you will be able to see this, and it will start the container. So, okay. So you should, again, if you fill out the survey, the initial survey with the second survey for registering, you gave your username, GitHub username. In my case, my GitHub username is Daniel-Acuna. So if you're not there, or if you're having any problem, please contact Lijian on Slack or on Zoom to tell him your username, GitHub username. Okay. Okay, so I guess let's try to log in and see if that may take some time, because many people are trying to do it simultaneously. But now pay attention to this part, because once you enter, you will see two folders. Okay, so one folder is datasets, and this folder has dataset that we will make available for you to use. If there is a new data set or some updates, we will do it here. And within this dataset folder is a subfolder called S4, which is the summer school. And here you have many data sets. So we have a sample of the Microsoft Academic Graph. We have the mentorship data set that we mentioned at the beginning, related to our paper with Stephen about mentorship, and other data sets. And Lijian will talk later about OpenAlex, so that we also have a sample here. Now we could put the entire data set, because MAG is like 500 gigabytes and OpenAlex I think is like 1 terabyte. So we don't have it here available, but we have a sample, and with that sample you should be able to access it in more detail. Or you can use that sample for your project as well. Okay, so I'm going to go back to the root folder. And in the library is where you will be working. Okay, so one important thing is that here you can create files. So if you go to new and create a file, it will create in this folder, in the library folder. Okay, and I would say that if you go back to the root and if you create a file here, let's say I create a file, some random file, some stuff there, and I create it, it will be created here. When you log out and log in tomorrow, let's say that file will be deleted. Okay, so don't put anything in the root folder. Okay, whatever you put put inside the library folder. Okay, in the library folder, this is going to be, save and store for you. I think we have students from last year who still use this. So hopefully the data and your analysis will still be here for the next couple of months to continue working if you find this useful. Okay. All right. So if you go to library and then to S4 lectures, this folder contains the lectures for this week and other things. So one of those other things in the additional resources, for example, never mind, in references is the project proposal guidelines and the mini grant announcement. This is two examples. Okay, so I will refer to this on Slack, but this is just one example. All right, now I'm going to go back to S4 lectures, and the number here indicates the day. And yes, this is being recorded, and we hope to post it today on YouTube or tomorrow at the latest, but today should be available there. So if you go to introduction, here, this first file is the file that has the presentation that I was giving today morning. Well, I guess like an hour ago. Okay, but I will go to the second one, basic Python. Okay, so if I click there, okay, it will open automatically. And let me explain you a little bit of what's happening here. Okay, just like the architectural form of this. Okay, so this environment is called Jupyter Notebook, and you may be familiar with this or not, but it's like an environment that allows you to run code through the web browser, and we have computers that are running your code. So you're basically sending code to the backend server, and then it runs something, and then it returns the results. And Jupyter was originally intended to work with 3 programming languages: Julia, that's the Ju part, Py, which is Python, and then R, which is the R programming language. So what was the original there? Jupyter. We're going to be using Python for the most part. I think most of it is Python, but you're welcome to use whatever language you use for your own project. But you cannot run those languages here, unfortunately. The only thing we have available is Python. Okay, so when you enter the system, and this thing that I was doing, browsing the file system, we're basically browsing your account. So here, when I click in these files and folders, I'm browsing my own space. Okay, so whatever you do here won't affect anybody else. It's just your space, your files. There are some special folders that get synchronized with GitHub repository. So it gets synchronized with another system. So for example, that one of those special folders is S4. So this folder, library S4 lectures, this will automatically update itself. So every time you log in, it will try to pull the data from GitHub and update. So for example, like an hour ago, I made some changes, like I messed up some numbers, and I update GitHub, and then the system here automatically pull those changes into my own space. All right, so these are the files. Now, when I open the files, I open them just by clicking. Okay, so if I click here, it opens this other tab that you see here. Okay, so this type of file is called an IPython notebook. That's why it's IPYNB, IPython notebook. And this notebook contains rich text, okay, with links and everything. And it can also contain, I'm going to go down here, it can also contain code. Okay. So, and this is Python code. So now there are many buttons here, and this is not the typical Jupyter Notebook environment, we added a lots of things so that you can see. So for example, this is one like additional plugin that allows you to, or this one that allows you to see the table of contents, and you have other things too. Okay. All right, so I'm going to start. So if you have any question, please let me know. The most important acknowledgement that I have to do is that there is no way we can teach you Python in one day. And Python is a relatively simple programming language compared to other programming languages. And that I know that some people here are in computer science. So if you compare it to C++, which is other kind of language, Python is much simpler. But it can, you can still do the same things, just that the syntax is cleaner in my view, but it tends to be slower than these other programming language like C or C++. So there are many, of course, resources available. So I usually suggest people to start with these 2 courses. Now, unfortunately, these courses are not, I don't think they're free, but they have like a trial on lynda.com, which is not lynda.com anymore, but I think it's LinkedIn Learning. So if I click here, it will take us to LinkedIn Learning. I'm logged in here so I can watch this, but this goes to like the basic Python. So that's just one example. Some university libraries subscribe to that automatically. So here are some other examples. Now you can install Python locally on your computer. So if you go to this link, you can download like basic. No, it's not actually basic. It's like a pretty nice distribution of the basic programming environment, plus many libraries that allow you to analyze data. And there are different ways of interacting with Python. One is to just use a good old editor like Visual Studio Code. You can use something more advanced like PyCharm, or you can use this environment. So I would recommend, if you're just starting to learn programming, or you're too busy to do these things, to use the environment that we have here in this website. All right. So I guess I explained a little bit about how the architecture works. So you have these files that you can run code, and then the code is sent back to the server, and the server executes it, and then it sends the result back to you. So that's pretty nice. Now, the basic structure of a Jupyter Notebook, which is what I'm seeing, what you are seeing here, are cells. Okay, so each of these things. So if I click here, I'm clicking. So if I move with my keys, I'm pressing my keys on my keyboard up and down. I will be moving up and down in these cells. Okay, so this is the first cell, the second cell, and so on and so forth. So this is the third cell. Now, if you see the border here is blue, and that means that we are in the, let's see, edit. It's not edit mode. This is view mode. So we are seeing the cell render. Okay, we're seeing the result of actually executing this cell. Okay, now if I double click on this cell, I'm going to double click. It will open the code that produces this cell. Okay, and the code, this is called Markdown Codes, and it's a way of producing rich text, but with plain text. So if you put like this £sign and then text, it will produce a heading. And if you put a number and then some text, it will produce a number list. Okay, so these are the content of the cell. Now, if I click the cell inside and it's green, it means that I can edit it. Okay, so if I edit here, if I write something, it will automatically update. Okay. Now, to execute this cell and hide this or see the results, I can either click here, run. That's one way of doing it. Or what I usually do, I double click again and I enter the edit mode. What I usually do, I click Shift Enter. So if I do Shift Enter, it will execute and automatically go to the next cell. Okay. And the last command that sometimes I use, I'm going to double click again to open the cell, is Control Enter. Maybe I should have like keystroke on the screen, but this is Control Enter. If I do that, it executes the cell, it renders it, and then it stays in the same cell. Okay. Now, there are ways of inserting cells. So this is like a non-linear execution. So you can actually, let's say, insert something before this cell and execute it. So in a sense, you are executing something before, but you're executing something after. So what you can do, you can insert cells. So let's say I want to insert some code here on some comments in between these two cells. What I can do, I can go here to this cell and then go to Insert, Cell below, and it will insert a cell. And as you can see, this looks different. Okay, and what's happening here is that there are mainly two kinds of cells in Jupyter Notebook. There are the Markdown cells, and you can see it here, the type of cell here. This is a Markdown cell because it has text. And there are, I'm going to click here, code cells. Okay, so in the code cells, you can put Python code. Okay, so I'm going to put some basic, some basic summation of two numbers. 2 plus 5, 2 plus 3 should be 5. Okay, so I put that code there, and I can run it in the same way that I run the Jupyter, the cell below the Markdown cell. So if I click run, it will execute this and give me the results. Okay. So are there any questions? Am I going too slow, too fast? And again, this is being recorded, but still, if you have any questions, please let me know. If not. Okay, good. So let's see, by a show of hands, maybe I should have started with this. How many of you have already worked with Jupyter Notebooks? Okay, 3. Good. Okay, so we have almost half of you already know Jupyter Notebooks, which is good. So there is a good chance if I put you in a random group, someone will know Jupyter Notebooks. So that's good. Okay. So let's see. So I can put Jupyter Notebook, Jupyter Cells. So now one of the things that I use all the time, I don't go here and click. I use this shortcuts. So A and B are shortcuts for the commands. But to execute those commands, you have to be in the view mode. You have to have the blue stripe here that says, I'm viewing the results. I'm not actually inside editing. Okay, so if I click outside, I can see in the view mode. So if I'm in the view mode, I can execute this shortcut. So I can, let's say, insert a cell above. So I'm going to click. I'm going to push the A key, and then I can insert cells. All right. So once you start creating code that is more, complex. So let's say I'm going to create like a hello world. So it's like a multi-line thing, very complicated program. And then I think someone said that they assumed that he speaks Spanish. So I'm going to say, hola. All right. So this has 4 lines, and sometimes when your programs get large, you want to see the line number. Okay, so to do that, you can you have to be in this mode, in the view mode, and I press the L key, and that shows the line number. And I like to look at it like this. All right, so there is a question for those who are experienced programmers. Is it okay to skip this lecture and come back later? I guess, but I'm not sure when Lijen is lecture is, and I hope to I think it might take like an hour, maybe less. At your own risk, I guess. All right, so delete cells. You can delete cells. You go here. You can, of course, delete cells with this command, or double D to delete cells. Sometimes you want to put comments. So let's say if you're putting some comments here, you can select those lines and press Alt dash forward slash, and it will comment all those lines, in one keystroke. Okay, so one important thing that I want to mention is that if you modify this notebook, let's say you're modifying this notebook, there is a chance that this notebook will get overwritten if it's a notebook that is part of this subfolder. Okay, because automatically every time you log in, this notebook will get overwritten with the new content. So if you want to save this in a new file, you can go here and click and change the notebook. So I'm going to say, personal, and it will change the notebook name, and that will be like a new file. Okay. So when you log back in, the system will automatically copy the server's version of the basic Python notebook here, so you can keep working. Okay, so what I would recommend if you're working on your own notebooks, okay, is to create a notebook here in the library. So you create a notebook like this one with this command. You go to new Python 3. You create it here. You say, okay, your basic, something like basic analysis. You work here, then you save with this command, and then you shut down, close and halt the notebook, and that will create your file and won't get overwritten because it's your own name. Okay, so sometimes you want to share the notebook with others, so you can download the notebook by going to File, Download As, and you can download as a Jupyter notebook and then share it with somebody else or with us, and we can try it. Okay, so to create a notebook, you go here to Library again, and you go to New, and there is only one kind of notebook with Python 3. And you click there, and it will create a notebook immediately. Okay, and it will create a name, but you have to, if you like the name Untitled, you can leave it as is, but you can click here to change the name. Okay, so Python is it's a very simple programming language, and it has, like any programming language, basic types. So it has integers, floating point numbers, booleans, strings, and it also has types that are combinations of those basic types. Now you can know the type of a variable or of an expression by using the type function. And here, for example, if you go here and click and then execute, it will tell you that the type of this expression is an integer. You can execute that. It will tell you the type of this expression is a floating point number, and so on and so forth. So Boolean, list, dictionary, tuple, float, tuple with one command. All right, so now one of the most useful structures is called a list in Python. So here I'm going to create a variable called x, and I will assign to it a list of numbers. Okay, and then I will create another variable called y that will have a list, but it will have different types. So here all the elements are of the same type, but in y each element is of different type. So this is a list. So if I put x, it will return what it contains, and I can apply multiple functions to it. So length will give me the length of that list, and the type list contains many functions to manipulate or to do something with the list. So one of those functions is called append. So with append, I will add an element at the end. So if I ask what X contains, it will tell me that it contains what I had before plus what I appended at the end. You can also concatenate two lists. Okay. So here I put all the elements of X, which are this, and then all the elements of Y, which are all of these. You can ask if if this element is inside X. Of course it is. You can ask if this element is in X, and it's not, so I will return false. All right, so let's see here. Okay, good. So I will recreate X again with 4 elements. So you can index the elements now. So you can say, okay, give me the first element of the list. Great, give me the fourth element. Now you have to notice that the index that goes in the indexing operation starts from 0. So that's different from R, for example, which starts from 1. So this is really giving me the fourth element, even though it says 3 here. Okay, so you can also slice this with this syntax. You can say, okay, give me the elements of X from here up to here, or before here, from here to here in this number of steps. Okay, so let me kind of explain that more. So if I put from 0 to 3, it will give me from the position 0, so the first element, all the way up to before the position 4th. So this is the 4th index. Okay, so it will give me the first 4 elements. Now, if I put 2 after that, it will give me these elements, but it will skip 2 because I'm going from 1, then I skip 2, and I go 3. You can also use negative indexing. So this -1 will give me the last element of the list. -2 will give me the second to last element, and so on and so forth. And you can combine these things. You can say, okay, give me the last, well, from I guess the third element counted backwards to the end. And if you don't put the stop, so here usually you have the stop position, you can omit it, and it automatically will consider this to go all the way to the end. Okay. All right. So we're gonna do the first group activity. Okay. So so maybe you haven't opened your notebook and you kind of got lost into what's happening. So I want you to at least go to this question and execute this line so that you have a definition of X. And I want you to answer the first question. How would you reverse a list? Okay, so this is the list. How will you reverse that? So I want the result that I want, desired result, of course, is 4, 3, 2, 1. And I want you to use these commands to do so. Okay. So what I will do, let's see. Carry how to breakout rooms. So we're gonna do, let's see how many people tweet. Okay, so we're gonna do 6 breakout rooms. Let's see. Okay, so I'm gonna do breakout rooms, and I hope to keep the same breakout rooms throughout the day today, so you can interact with the same people. And I think I will join. So that's kind of cheating, but let's see how that works. Are there any questions about what's going to happen now? So you're going to go to the breakout rooms. You're going to discuss what's happening and hopefully agree to a solution to this little question. Okay. And you should have like a request to join a breakout room. All right, welcome back, everybody. Might have been a little anticlimactic. I didn't let you know that I will be pulling you out of your breakout room, but I hope you got to talk a little bit or not just solve this challenge. So let's see, what do you think the solution is? And I don't think the solution is here. So how do you solve this challenge or this question? Right, so you can now I didn't know about reverse, so that's good. Oh, okay, here. Okay, we have three solutions. So this, now can you explain what this is doing? What is, how would you explain this? Yes, feel free to unmute yourself because it's like unintuitive. What's happening here?
Actually, as you told us, we have three things. We have something like a start, we have something like a stop, and something like a step. Can you hear me?
Yes, yes.
Okay. And you know, when you do not put anything on the first and the second slot of the brackets, it means that go from the start to the end. But actually, we have something like a part named step, which means that we are going to do with each step. And -1 means that just do the reverse part. So, you know, starting by the first one, you know, we are just coming back and back because, you know, the list is rotating. So because of that, we can use it. And also it is a local part. Yeah, it is, you know, it doesn't change the X if you use it. It's really good.
Great. Okay, so I can see this and it's reversing. I'm going to try the other solutions, which I actually didn't know existed. So reverse. Oh, I see. Okay, so now here's a little so this doesn't, as Yas said, it doesn't change X. Exactly. So this doesn't change X, so it will return a copy of X. But it doesn't change it. So so if I execute X after, it will show me 1, 2, 3, 4. Now I executed this, and as Matthew is saying, this will reverse it but change it in place. So it will like change the contents of X. So if I execute X and I see what it contains, it will contain the reverse version. So, and as also he's correctly pointing out, this doesn't return anything. So if I do type of this, it will say none because it doesn't return anything. It changes the variable in place. So if I ask what X contains again, it will contain the same, the reverse of the reverse, which is the original list. Okay, and the other one was reversed X. Let's see. Okay, so reverse X is returning, and this we don't necessarily need to get into in too much detail, but once you study Python more, you will see that there are this concept called iterators, and to see the contents of an iterator, you have to use something like list so that you can actually get to, you know, iterate the list. They will give you back the same idea that you have here. Now, which of these is faster? Nobody knows. We can do like a little exercise to see which one is faster. But okay, great. Okay, so let's continue. So list comprehensions are a very powerful way of creating lists out of arbitrary elements that you want to produce. So and the syntax is a little bit, you know, it might take some time to get used to, but basically you have 4 elements. You have, okay, what are you going to iterate over? What are you going to call each of the elements of the input sequence? And what are you going to if you want to select, subselect some of the elements, and what are you gonna do with the elements? Okay, now that's all confusing. So let's try one thing. So first, I will explain what this is doing. So range is one of these things that I was explaining before. It doesn't really do anything. It doesn't return anything. So I have to cast it first. But basically, range just creates a range of numbers from 0 to 9. So it doesn't go all the way up to 10. Okay. So what I want to do, I want to go through each of these elements and do something with them. Okay. So if I do this, I'm not doing anything. So I'm saying, use the variable a to take over each of the elements in this range, and then for each of those, just return or produce the same I in the range. Okay, so this is not really doing anything. It's just going through it, and it's like an identity function. But if you do something like this, then you're saying, I'm going to take each of the elements in the range and I'm going to square them. Okay, so this double asterisk in Python means squaring. Okay, so it's going to return the first squares from 0 to 9. Now you can do some more advanced things. You can say, okay, go through this through the lists, but don't return elements for which this is, well, I guess return elements for which this is true. Okay, and that's only going to return the elements from 6 to 9. And you can do anything inside here. So this operator is the mod operator, and it basically returns the modulus with integer division. So if I do, let's see, 3 %2 means I'm going to divide 3 integer division. So 2 fits once, and I have a remainder of 1. Okay, so if I would, when I do the division, the remainder of that division is 1. So this is basically saying, if the remainder of the division by 2 is 0, so if it's divisible by 2, return the number. So this is basically saying return only the even numbers. You can do nested comprehensions. So you can do for each element of this outer comprehension, I'm going to do a little comprehension inside. So this will return a list of lists. It's basically like a matrix. And you can also concatenate multiple comprehensions. So you can do several in a sequence. So here I will return all the combinations ij from 0 to 5 so that I is less than j. Okay. Okay, strings and many collections in Python, you can treat them as lists or as sequences as well. So you can do all the things that we did with lists below, we can do above, you can do them with strings. So this is a string, and you can access the different characters by using the same syntax that we saw below above. You can take every 2 characters and you get like a weird string. And you can reverse the string. Okay, I'm going to use the syntax that I had above. So this is reversing the string. Now a string has like a host of other functions. So has many functions that work specifically with strings. And one of them is split. So it will take the string and it will split it by default by space. And it will return a list of all the words basically in the string. You can do the reverse operations. You can take a list of words and you can join them into one string, and you can provide the glue that it would that will use to glue the words in the list, and you can use any glue you want. I'm using dash here. And a string has many operations: lower, upper, or replacing a word with another word. Now, tuples are like lists, but you cannot modify them. So Z is a tuple. Remember from above that X is a list. And with a list, I can modify. I can say I'm going to replace the second element with a -10. I do that. I changed the second element with 10, but you cannot do that with tuples. Doesn't kind of complaints because it's a much more efficient way of storing. So it makes some optimization so that modifying it is not possible. Okay, so and then we have dictionaries. So it should be relatively self-explanatory. Dictionaries is a way of storing information. So you can have a key giving you the result. Sorry, it's for storing value so that the value has a name. So you can think of it as a cell, as a database, and you're basically storing one row of a database. So here, for example, I'm creating a dictionary. I'm going to do this first. Create a dictionary S, where I have the key name, the value is above, the GPA, the key GPA has a value of 3.4. And I can add elements to the dictionary by using this syntax. I want to use the put a new key major with value IM. Okay. And then I can retrieve the elements of the key, the elements of the dictionary by using the key. Now here it complies because this S doesn't have the key H. Okay, so it throws an error, but I can get away with that. Let's say if I want to ignore that this key doesn't exist, I could say, okay, if this doesn't exist, return an empty string, or I can say H -1, like a nonsensical H, and it will return that where you put a second argument. All right. So program flow the syntax is very nice if you've used other programming languages. So I'm gonna do like some basic arithmetics here. So I'm gonna create, say, a bank account. So I will say, okay, I have $100 and I want to withdraw $200. So I could say, okay, let me add the condition that if I have balance in my account, so I can say, okay, is the account balance greater than 0? It will run this and it will return a Boolean number. And then you can say, can I withdraw $200? Well, to do that, you will need to say, well, if I withdraw $200, will I have any balance left? And the question is false, because the withdrawal amount is $200. And you can have this very nice syntax where you can have like a more mathematical definition. I want to know that the balance is between 0 and 100, which is the same as having two conditions together. Okay, I'm going relatively fast over this. Please let me know if you have any questions. If controls could be a little, if you haven't programmed in Python, could be a little weird. Okay, and I will explain why. So let's say I want to do like if account balance is greater than 200, which we know it's not. So I'm going to print, balance is, low or something like that, something like that. I mean, high, sorry. Now, the way that this works is that if this condition is true, it will execute everything that is in this block. Okay, and the way that Python manages blocks is by white spaces. Some programming languages use a special character, like in R, you have to put brackets, and that will represent, this is the thing that you will execute if this is true. But in Python, no, the way to create blocks is simply by spaces. So if I execute this, it will print, balance is low because account balance is 100. Okay. But I could add more things to this block. I could say, please deposit more money. Like that. So it will execute these two commands because they are part of the same block. Now, there is not really a set number of spaces that you need to use. I think in the notebook here is automatically 4 spaces, 1, 2, 3, 4. But you can use, let's say, 2 here and 2. I think it still works. Okay, doesn't matter. I think you can use even 1. Yeah, it still works. So it doesn't matter. Yeah, as long as you're respecting this space in between the blocks, then it will work. The same with while loops. You have to put the block here. It will execute while this condition is true. The same with for loops. Okay. So here's some examples. Okay, to define functions, it's also very, very simple. You have to use a special keyword def, and I'm defining the function f, which just returns the value 5. So if I execute it, it will return 5. Now, you can see here that I have this weird little string. So this, if I put 3 quotes, single quotes, I will create a multi-line comment. So, and in this multi-line comment, I can put all comments about this function, and this will become the help of the function. So if I use this little syntax $f, it will show me the comment. Okay, so this text here that's just below the definition will become the help for this function. Okay, so here I can define, of course, more complicated functions where I define different parameters. So here I'm going to add 2 numbers, or I'm going to add just these 2 parameters. But in Python, it doesn't matter what I put. It doesn't care about the type. So I could just as well add 2 strings, because just taking these 2 things and applying this operator doesn't matter what I put. Of course, if I put like, a tuple and a list, it won't work because I cannot modify the tuple. So I cannot concatenate this with this. But if I put something that supports plus, it will work, no matter what. Okay, any questions so far? Okay, so once you get to do more sophisticated analysis, you won't be dealing with basic data types, with integers, lists, tuples. You will be dealing with objects. And once you're dealing with objects, you need to see that what are the kinds of things that they can do. So the main, and maybe I don't know if Lijian will use this, but the main way that in Python you analyze data, usually you start with something called Pandas, and we'll get through it tomorrow, but it's a way of reading tabular data into Python. So if you've used R, it's data frames. It's like basically like a spreadsheet where you have columns of different types and you have names for the columns. But sometimes you will be analyzing numerical data, arrays, matrices, vectors, and for that, there is a package called Numpy that can deal with that. Okay, so I won't get into much detail, but basically here I'm creating an array of numbers, 5 numbers. So it's now this variable ARR is not really a list anymore, it's an array. And Numpy allows you to do all kinds of stuff with these vectors. So the way that I explore this personally is I use dot, and then I press tab. So if you press tab, it will show you the functions that you can apply to this array. The more correct terminology is called a method. So I can let me take the mean of the elements. Okay, so if I execute that, it will tell me that the mean is 3.5, 3.6. And you have all kinds of other things that you can do. Now, sometimes you want to see, well, let's say I don't know what Rmax does. Okay, let's say you don't know what it does. So you can write it like that. You can put the parentheses, and then you can press Shift Tab. Okay, the key Shift and then Tab, and it will show you the help of the function. Okay, and then you can click here, for example, and you can read more about what this argmax does. Okay. Any questions? All right. So so before Lijian, let's do one more activity so that and I want to test that it will work so that you work with the same people again. And the activity is it's you might know it or not, but it's a question that came up a couple of years ago to filter people that claim that they could do data analysis, but in reality, you know, they were just learning and just fishing for jobs. So there was this famous interview question called the FISBUS interview question that, according to this post from many years ago, was a way of filtering candidates very rapidly. Okay, so the question is as follows. Okay, so we want to write a program that prints the numbers from 1 to 100, but for multiples of 3, I want you to print FIS instead of the number, and for multiples of 5, I want you to print BUS. However, for numbers which are multiples of both 3 and 5, I want you to print FISBUS. Okay, so basically your program should print 1, 2. When I get to 3, because 3 is a multiple of 3 by definition, I should print FIS. 4 is not a multiple of 3 or 5. For 5, I want you to print BUS. 6, 7. Well, 6 is a multiple of 3, right? So this should be FIS. 7, 8, 9 is a multiple of 3, so it should be print FIS. And then I messed up. 5 is a multiple of 10 is a multiple of 5. And then 11, here my math is breaking down. And then 12 is a multiple of FIS, right? 13, 14. Okay, 15 is a multiple of FIS. Oh, sorry, it's a multiple of 3 and 5. So it should print FISBUS. Okay, and so on and so forth, all the way up to 100. Okay, don't look it up. Don't go to Stack Overflow. I'm sure there are a trillion ways of doing this. Okay, so I want you to create this in Python, and the way that you will do it with a for loop. So it should look something like this, like for, you have the number in, you know, you will do from 1 to 100, and then you will do your logic here, please. Okay, so you should use if, you should use this operator, the mode operator, etc. All right, so let's take you again to the breakout room. I'm gonna pause recording, so I don't stare at the screen for the recording, and let's see how this works. So let's take like 5-7 minutes, okay, to discuss this, and then we come back. All right, welcome back. Now, this is, I mean, if you're, you know, starting to program, this might be a confusing problem. So don't think that because you couldn't think of a solution, there's something wrong with the process. It's really hard to learn at the beginning some of this bifurcation of different things. So let's see. Anybody wants to volunteer at least the gist of their solution, or maybe their solution entirely? One at a time, please. Now, we also did. We did it. Okay, good. Sorry, I wasn't reading the chat. Excellent. Congratulations. So would you like to share with us how you did it, Oscar? Okay, great. Okay, I'm gonna, like, in a good Stack Overflow fashion, I'm just gonna copy and paste. Okay, so let's see. We have 2 solutions. Let's see. Oscar. I'm sorry if I'm mispronouncing that. So this is, I'm I know that it's multiple people helping, but I'm gonna use that. Okay, so what's happening here? Okay, good. Kita. Okay, here acknowledgements. I guess here we have acknowledgements thanks to okay, good. And then this is Kita. Interesting. So we have some variations, which proves that you're not cheating, which is good. This is just. We have Matthew. Good. Okay, so let's go one by one. So here we are all using the same. So range really goes from the start until one number before this. Okay, so it should really be 101, and we can prove it, right? We can take this into list. Okay, so they will go until 99. Okay. Now, would you like to explain Osgur or Adarsh your solution? Maybe that will work out better. Or you know, just some gist of what's happening here.
Adarsh?
Yeah.
What?
Yeah.
Go ahead.
Yeah. Yes, sir. Maybe first check the multiplicity of the numbers. For the first condition, if n mod 15, the number which is divisible by 15 means the number which is divisible by 3 and 5. Then print the fuzzy buzz. And in second condition, if the number is divisible by 3, then print the fizz. In the third if condition, if number is divisible by 5 only, then print the buzz. Otherwise, it print the numbers, that is a 1, 2, 4, 7, and so on.
Right. So I'm going to execute this. There you go. Great.
Yeah.
Good job. Now we're missing 100. Oh, it's not 100. What should it be? Let's see. Carry the 1, should be 5, bus, right? Or something. Great. Now this Ankita, do you want to explain this?
Yeah. So similarly, I went around like for if the number is in the range 1 to 101. So like it will print number, it will take numbers from 1 to 100. And then if the number is divisible by 3 and 5, then it will print fizz buzz. Or else if n is divisible by 3, then it will print fizz. Else if n is divisible by 5, then it will print buzz. Otherwise, else we'll be using else command, and otherwise it will be printing the number as is, the n.
Cool. Great. Now this is more explicit. Like we're saying if it's divided by 3 and divided by 5, whereas the previous solution was 15, kind of did a little bit shortcut there. So this is great. Now this is like a very, very nice. Can I call it a hack? I mean it like as a compliment. Yes. You want to explain this? Yes.
Yeah, I was telling that, okay, we just have something like 3 and 5, and 15. Okay, one of the things that we should print is just sticking one of the other to the another one. So just do not do the, I percentage 15 is equal to 0. So let's say what? Just have a string that we are going to print. If it is divided by 3 and the remainder is 0, we please add fizz. And if it has 5, just add buzz. If it has 3 and 5 simultaneously, it's going to be fizz buzz. And if this string is not the string that we just initialize it, we are going to say print a string, and otherwise just print the I that we have. That's the solution that I just gave.
Yeah, exactly. So this kind of saves a little bit. And then I believe this is Matthew's group. And it's similar idea, Matthew, right?
Yeah, same idea, except I have a really embarrassing penultimate line there at the end as I was trying to rush it as the timer ticked down at the end. But we tried to build that out of like, we knew we wanted a for loop. And so I just tried to walk through this. Like,
Yeah.
I like to, if I know what I want to do and have a structure, like put in the comments and then figure out how to implement those comments to build the code.
Yeah.
But
Very
same
good.
functionality, except for the silly part at the end.
Now there is a typical mistake that people make in this problem. Anybody made kind of got into that little error? We can all share it. I made it too when I did this first. What is a typical error?
The typical error is
Okay,
that
you're
don't
the
account
greatest student.
for-
Oh, sorry.
Oh, sorry, I should raise my hand. The typical error is that you don't count for the fizz buzz. So you end up just
Exactly.
putting up fizz or buzz, whichever one was first in your code.
Right, right. Yes, you have to realize that you have to check. Well, not in this little hack. This is a nice hack, but basically you have to check that you have to, make sure that first you capture divisibility by 3 and 5. Do not put in colon and spaces. Oh yeah, the syntax for blocks and ifs it can be a little confusing in Python. That's true. Okay, great. So, any question so far? I hope you're having fun. I hope this is now again. There's no hope that I can go through Python. I'll go through a little bit more tomorrow, Pandas and Numpy, and maybe some plotting. But please explore as much as possible. And I think there is some discussion amongst the organizers to have maybe a little bit of tutoring for Python, like deeper, and maybe going into this. I think that will happen. I guess we can share some of that later, right? Lijen, Han, and Stephen. Yeah. I see. Okay, good. Okay, great. So let me stop my sharing. So as I mentioned in the beginning, one of the things that really had got Science of Science exploding is the ability to access these massive data sets that are available. And there is this beautiful, I call it beautiful because it's like a really work of love to create a replacement for Microsoft Academic Graph, and that replacement is quickly becoming OpenAlex, which is this massive data set of publications, citations, is disambiguated, and they're doing a really good job, and they're very open too. So they're open to collaborate, to advertise what people are doing with their data